Matrix powers. So matrices, say you got a matrix A, which equals something like this, can be put to any power. But the important thing to note is that you can only do this for square matrices. So you can only square a square matrix. Now, you've already also maybe seen some other videos where we talk about solving simultaneous equations, like -1, which is the inverse, is also a power, and that has to be for a square matrix. So you can take any matrix and put it to a power as long as it is a square matrix. Now, some special cases. So you know that like 1 times 1 equals 1 squared, which is just the same as 1. So it doesn't matter what power you put 1 to, it equals 1. And the same thing happens with I. So you have I times I, that equals I squared, which means it equals I. And I've just done that on the calculator over here. So I to any power equals I. And just to further show that's true, I to the power 23 does in fact equal I. I've just done it over here on the calculator for a 3 by 3 I. It's true for any I. And another special case, I've talked about this on the permutations video, but P to the power n eventually becomes I. Okay, so over here I've got my matrix P, which I've just labeled into my calculator over to here. And then I've done P squared. And no, that didn't equal I, but maybe you can do it to a higher power. And here we go, we've got P cubed does in fact equal I. So there might be something that you ask on an exam question. So like P to the n equals I, what is n? And you could say, well, 3 or more. Remembering, of course, that once you've got to I stays as I. Now, besides the special cases of I and P, it's also used in communication matrices, which is coming in future videos, where you have T equals C plus C squared. Dominance matrices, where they often talk about C equals D plus D squared, which looks very similar, but there's a difference that you'll see in the videos. And then this big thing coming up, which is transition and steady state, where you use powers to prove things. So next videos.